Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you're going to do remove, replace, reduce. You're going to remove the 16 and you'll have x squared plus 56x plus 784. And then when you replace it, you'll have 16x plus 28 times 16x plus 28. Both of those will divide by 4, so you'll be left with 4x plus 7 times 4x plus 7, which you can also write as 4x plus 7 squared. Okay, for the math knowledge question, it wants to know how many horizontal or vertical asymptotes are there. Well, we know that there is going to be a vertical asymptote at 7 because our denominator cannot equal 0. So we know we have one asymptote here. There's another asymptote, but it's not horizontal or vertical. It's actually got a slant like this. And so we only have one that is horizontal or vertical. We'll learn more about the slant later in the year, but for now, you just have to know about the horizontal and vertical, and it just said only one for this one. So we're going to be looking at lesson 53 today. We're going to be doing a quick review of unit multipliers. You did that in Algebra 2, and then we're also going to look at angular velocity. This is the new part. So hopefully you'll remember your unit multipliers, and then you'll get an understanding of the angular velocity after we go through that. So unit multipliers contain units such as feet, meters, hours, seconds, and they always have a value of 1. So here are some unit multipliers that we've dealt with before. Hopefully you know all of these. There are 12 inches in 1 foot, 3 feet in 1 yard, 5,280 feet in 1 mile, 100 centimeters in 1 mile, 1,000 cubic centimeters in a liter, 1 inch is 2.54 centimeters. There are 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day. If you don't know any of those, write them down and learn them tonight. You may need them, you may not, just depends on the problem. So we're going to go over how to convert, just in case you have forgotten. We're going to change 40 miles per hour to meters per second. So 40 miles per hour. So pick either miles or hours first. I'm going to pick hours, and we're going to change it to second. So there is 1 hour for every 60 minutes. And the hours will cancel. Then there is 1 minute for every 60 seconds. And so the minutes cancel. So now we have it in miles per second. Now we need to get miles into meters. So 1 mile is going to go in the denominator so that the miles will cancel. And there are 5,280 feet in 1 mile. Now we convert from feet, we can go to inches. So there are 12 inches in 1 foot. So now the feet cancel. And then we can go from inches, there's 1 inch to 2.54 centimeters. And that'll make the inches cancel. And then the last thing we can do is to go from centimeters to meters. So 100 centimeters to 1 meter. And then those will cancel. And so now we're just going to write it as 40 times 5,280 times 12 times 2.54 all over 60 times 60 times 100. And our units in meters per second. So that would be your answer. Hopefully you remember doing that back in Algebra 2. Maybe you've done it in another science class, but that's what you do for unit multipliers. So now we're going to be looking at angular velocity. Linear velocity is a vector quantity because it has both a magnitude and a direction. Angular velocity is also a vector quantity, and it measures the rate of rotation of an object. So linear velocity is how fast a car is moving. It's going 70 miles per hour. That's a linear speed. How fast you run on the football field. If you run a 100-meter dash in 4.2 seconds, I don't know if that's reasonable or not, but that would be a linear velocity. Riding a bike, swimming, any of those that you measure in a unit per time is linear velocity. Angular velocity is also vector, but it measures the rate of rotation. So how quickly are your tires rotating would be an example for angular velocity. Your direction can be counterclockwise or clockwise. Your units for angular velocity are going to be a circular measure per unit of time. So not meters, not miles. We're going to do a circular measure. So that would be one of these. Degrees per second or per minute. RAD is radians per second per minute, or revolutions per second per minute. So it's how fast it's going around in a circle. So that would be in degrees, radians, or revolutions. Your formula you're going to want to use for finding linear velocity on a rotating body is L equals R omega. So omega is that last variable. It's angular velocity. The L is your linear velocity. The R is the radius of the circle that's rotating. Your omega is always measured in radians per time. If your angular velocity is given in revolution per time or degrees per time, they have to be converted to radians to be able to find your linear velocity. So this is looking at your circle. To find your linear speed, you're just going to do your R times your omega. Your omega. To find your linear speed, you're just going to do whatever R times your rotating angular velocity. The further away you are from the center means the faster you're going to have to be spinning, because you're going to be going at a faster rate to stay in line with the part that's closer to the center. If you've ever been on one of those rods that spins you around in a circle, the closer you are to the center, the less you're going to turn. The further out you are from the center, the more quickly you're going to turn. You're going to get dizzy a lot quicker. So let's look here. The best way to do these is to do an example. We're going to start with our formula. So L equals R omega, not W. This is omega. And you're going to fill in the information they give you. They tell you the radius is 14 inches. And on these, you're going to want to put your units, because we're going to have to do a unit conversion. And then it's revolving. So that's your angular speed, because it's revolutions per minute. You wouldn't say that you're running at 40 revolutions per minute. So that's also how you can help know that it's an angular speed. So that would be our angular velocity and our radius here. And then it says how fast is the wagon moving in miles per hour. So we're solving for our linear speed, and we're going to have to get it into miles per hour. So I'm going to change the minutes. 60 minutes is 1 hour. So that takes care of converting that part of it. And then I need to convert the inches into miles. So 12 inches is 1 foot. Then your inches will cancel. And then 5,280 feet is 1 mile. So that cancels that. Now the only problem, we're not in miles per hour yet. We are in revolutions times miles per hour. So the way that we're going to get it into only miles per hour, we have to change revolutions into radians. So revolutions is going to go in the denominator, and that's how it'll cancel. 1 revolution is 1 rotation around the circle. 1 rotation around a circle is the same thing as 2 pi radians. Now once you have it into radians, You are allowed, if you don't need the unit radians, you are allowed to cancel it out and just make it disappear. You can't do that to revolutions. Radians is the only one that if you have it and you don't need it, you just mark it out. Okay, so now we're going to write our answer. 14 times 40 times 60 times 2 pi all over 12 times 5,280. Whoops, I put an extra 0. And then miles per hour. So radians is the only one that you can cancel out. If you try and cancel revolution, you're not going to get the right answer. Okay, so let's look at another example. This one asks us to find the angular velocity. So that means we're going to be solving for our omega. The diameter is 30 inches, so that means that the radius is 15 inches. And then we're traveling at 40 miles per hour. So that's what information they give you. So we're going to multiply both sides by 1 over 15 inches to make those cancel. And so my omega is going to be 1 over 15 inches times 40 miles per hour. So I'm going to start off by making it into seconds. 1 hour is 60 minutes. And then 1 minute is 60 seconds. So that takes care of changing that part. Now we need to change the inches and miles. And what's actually going to happen, 1 mile is 5,280 feet, and 1 foot is 12 inches. Your miles cancel, and your feet cancel, and your inches cancel. And so now we only have per second. There is no other unit in this problem right now. So if you look, we have 40, 5,280, 12, 15, 60, and 60. But our units are only per second. So now we need to get it so that it's in revolutions. So on the last one, we had a radians and we didn't need it, so we just marked it out. On this one, we need something, and so we can't put revolutions. That's what we need. We need revolutions. We can put radians though. Radians are special. If you need it, then you put it there. And if you don't need it, you just mark it out. And so now that we have radians there, we can transform radians into revolutions. So 1 revolution is 2 pi radians. And so that'll make it so that we have revolutions per second. And so our answer would be 40 times 5,280 times 12, and then over 15 times 60 times 60 times 2 pi, and then revolution per second. So that would be your answer there. So hopefully that helps you a little bit with your angular velocity. You have to be very careful on the radians part. Radians is the only one that you can drop in or take out if you need it or don't need it. Okay, so on your homework you have 1 through 30. Make sure that y'all do those tonight so we can go over any questions you have tomorrow.